Welcome, everyone, to DevNetwork's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome you all to this week's featured webinar presented by NGINX F5, the unit for developers, how to organize your application environment without using Docker. Before we get started with speaker introductions, I've got some housekeeping items to review. Number one, we've got live chat and Q&A available during the session, and you can raise your hand in the chat or ask questions in the Q&A section of the webinar viewer. That is on the right-hand side of your viewer at the top. Click on Q&A and throw in your questions. We will have the chat going on throughout the session as well. There are handouts available, so be sure to click on the handouts section to download the materials before the end of the webinar. This webinar will be recorded and made available within 24 to 48 hours for additional viewing, so you'll be able to take a look at it afterwards. It will also be sent to those people who didn't get a chance to come, as well as you can forward it on to your coworkers to check it out. We will be handling Q&A throughout the event, and answers will be coming in the Q&A section of the viewer. Joining us today, first of all, Timo Stark, who handles professional services at F5, and Liam Crilly, Director of Product Management at F5. So, without further delay, please give your undivided attention to Timo and Liam.
Hi, everyone. I'm Liam. I'm going to kick it off. So, first of all, as everyone else has been so great telling us where everybody is, I'm calling in from the UK, near Cambridge. And Timo, say hello.
Yeah, hi everyone. Pretty international audience, and yeah, my name is Timo Stark, and I'm joining from Germany, from the area of Munich.
All right. So here's what we're going to do on this webinar. I'm going to chat briefly about a little bit about NGINX, in particular NGINX Unit in this case. We'll hand it over to Timo. He's going to talk about the main content of the webinar around software development with NGINX Unit. That will include a demo, exciting times, and then we'll try and pick up questions as we go. Timo will answer while I'm talking, and vice versa. And if we've got anything left over, we'll wrap it all up at the end with another Q&A session. So feel free to pop your questions in the chat or the Q&A section in the webinar tool. Whatever you like. All right. So I know this event is about using Unit in application environment without using Docker. We mean no ill will to Docker. We love Docker, and NGINX and Docker have actually had remarkably similar timelines. So I wanted to get off on the right foot. This is not about replacing Docker for replacement's sake. It's about showing what's possible with NGINX Unit. So I'm going to get rid of my own poll answer here, but feel free to let us know. We've got more than one NGINX project in the world, so let us know what your experience level is with the various NGINX projects, and I'll run through a quick timeline here. So 2004 was the very first release of NGINX open source, but it was a bit of a quiet project, and partly because most of the documentation was in Russian for many, many years. It wasn't really until 2007 that the original author and founder of NGINX, Igor Sysoyev, sort of in his own words declared it as viable for production use in 2007. But then, big milestone in 2011, version 1.0 of NGINX open source gets released. NGINX Inc. is founded as a company to help maintain the open source project and build a commercial offering around it. And Docker did exactly the same thing, right? So we've taken two much loved NGINX open source projects in the community, maintained them, and wrapped a business around it as well. Interestingly, the first year of our NGINX Plus commercial product got launched was the same year that Docker's initial release happened. Later on, as Docker adoption has matured, we moved on from having just one project with NGINX, the web server, and in 2019 we overtook Apache and kind of the web server stakes from the most popular web server on the internet. We are also doing other open source projects. We have an open source project called NGINX JavaScript, which is a programmatic extension. So you can extend NGINX with the easy to use, easy to write JavaScript code. And we also started NGINX Unit. 1.0 was released in 2018. Fun fact, on the same day of the year as NGINX was originally released at 1.0. The day of International Human Spaceflight on the 12th of April. So NGINX Unit is different to NGINX open source. And that's the problem with having an eponymous software that becomes the company name and the brand. You have NGINX, the web server, reverse proxy, the load balancer, API gateway, all the different use cases, proxy cache, right, that people use NGINX for. It continues to do that very, very well. And now I have NGINX Unit. And NGINX Unit tries to solve a different problem. And there is some, but overlap between the two. So I'm going to double click on what NGINX Unit is really all about. And it comes down to this. NGINX Unit runs your application code. You know, it's an application runtime or an app server, depending on the language that you typically use. You might have different terms for these things. But the key point here is that it runs your application code without needing additional proxy or having to have a reverse proxy in front of the code, because NGINX Unit is also a proxy, or that is, it also runs on the network. What this means is you're able to run multiple applications through a single configuration style for multiple languages, and you're able to run multiple applications within the same NGINX Unit instance. So what this allows you to do is maybe it's a WordPress application, maybe it's something written in Python, written in Go, written in Node.js. You can run all of these applications in all of those languages, configure them all in the same way, and run them all in parallel. And you can do that also safely with isolation. So we can run different applications in C groups. We can have rooted environments to avoid file system overlaps. They can run with different users, right, in different permission scopes. So a great deal of isolation as well as flexibility around the runtime. And that's one of the reasons why we happen to solve indirectly some of the same challenges that the containers provide, but in a much simpler way. Final point here is that we also have the same high performance HTTP interface for all of your applications, regardless of the language. And of course, this is written by the same team that brought you NGINX, the high performance web server reverse proxy. So you know it's going to be good. I'll mention that again in a moment. So two different ways to think about NGINX Unit. Right? So first of all, for your older languages, and I'll explain why I'm prefacing it this way, you get to modernize those application runtimes. Right? So you get to have a better HTTP interface. You get to simplify the application stack. So Python, Ruby, PHP, you no longer need an FPN, you no longer need a unicorn, a G-unicorn, a rack interface. Anything with a server gateway interface is built into Unit. And very nicely, you get to run TLS all the way into your application. More of an operational production concern. But if you're terminating TLS inside the same runtime as the application code, you've got a very, very small gap that's plain text, almost none. So the security posture is also very good. Now, there's more languages that we support, and I'll call these cloud native languages. And you might say, yeah, but these languages come with an HTTP interface, so how does Unit help me with this? Well, there's a couple of reasons. Firstly, you get that high performance HTTP listener. Node.js has an HTTP engine written in JavaScript. Ours is written in C. It's going to be faster. And at the point that you're running more than one application, you get to configure all the applications regardless of the language, all in the same consistent way. And if you're automating any of that, That's a real benefit. So the key point here is that NGINX Unit combines layer 4 on the network all the way through to the application runtime and user space through a single configuration. So that spans the entire stack. And so this slide is a little bit detailed as to the internals of the configuration objects and the directives that you pass to Unit to configure it. But the idea here is just to show that we span layer 4, layer 7, and user space in a single configuration construct. And that gives you a lot of flexibility and power for taking your application code and actually running it effectively, simply. And the way that you can collapse the number of different components you need in order to run a single application, let alone a complex application or a microservices application that's got multiple components. And that is what Timo is going to cover. Before I get there, I've talked about configuration spanning the layer 4 up into the runtime. And that configuration is provided through a JSON REST style API, where you provide your configuration updates in JSON objects using conventional HTTP methods. And that might be over an HTTP interface, it might be over a local Unix socket for security reasons. And it gives you a very clean imperative configuration style for what you want your application server to be doing and how you want to configure your routing and getting network connections from clients to the correct bit of application code, or serving a static file, whatever it takes. So you can have a complete application, mix of dynamic and static content, some of which might be proxied, some of which might run application code, and some of it might be files on disk. And that entire construct that spans your entire, all of the scope of that application is now embodied in a single JSON configuration, which makes it super easy to automate, super easy to template, and gives you one place on your system where you've got all of that configuration in one place. So that's the setup. And I'm going to hand it over now to Timo, who's going to walk you through how this really happens for you developer folks in the real world. And I'll hand it over now, Timo.
Thanks, Liam. So first of all, thanks for joining, and I'm really proud and happy to present how it all works. I will just do a couple of slides, couple more minutes, and then we really dive into the hands-on demo. So first of all, what we are going to build here is a small front-end application written in JavaScript using the ReactJS framework. I think most of you will be aware of ReactJS, and it's well known. And we are connecting our ReactJS application to an API or two different APIs. One is written in Python, one is written in PHP. I mean, it's a common use case, having multiple services behind a front end. So we need to send data back and forth to receive responses on our requests and all that stuff. So this is all personal experience, not really constructed from what could be. I started the Docker journey 2015, and so that was what you can see here was like how my developer machine, how my MacBook or my workstation looked like at the beginning. I had multiple containers running, hosting my different services, and then I had a NGINX reverse proxy handling my routes, so that I can use in my application something like /API instead of localhost port 8080 and do some important, interesting things on the React side. So that was my setup, really. So use Docker a lot, and if you're using that kind of a setup with multiple containers at the same time, trying to organize your application development workplace, you definitely aware of those commands: docker cp, docker run -v, mounting stuff in the container, docker exec, go into the container, change something on the fly. If you mount something from outside, then most of the time you have to show 777 just to make it easy on your dev machine, all that kind of things. And that personally annoyed me a lot. But what Liam said, this session is not about like finger point Docker and saying, look, this is not great. I love Docker. I use Docker in production very, very heavily. And even on my machine, I'm using Docker for different things. I mean, all my database setup, my SMTP tests, if I have any, Elasticsearch, things like that. It's all run on Docker on my machine. So it's definitely a good thing, and this is very, very important personally for me to point that out, that it's not about replacing Docker entirely. It's more about making your life at some specific points a lot easier. So this is how it can look like, or this is how it looks like at the moment on my machine, and this is what we'll see in the demo. I replaced Docker for the application runtime entirely, and using NGINX Unit to host my Python API, my PHP-based API, and my ReactJS compiled or built frontend. So that means it is, I have my local environment for the engineering part with npm start localhost 3000. This is this little white application frontend code here, and I can test my build-it API or my build-it frontend with NGINX Unit as well. So I mean, I type docker or npm build. I have my static files. I push it to Unit, then I can test it right on my machine without any very, very special setup if it's working in the way it should be. All right, so that's what I mean. Just a couple of slides, and now we can jump right in the demo. All right. I get rid of the. All right. Good. So basically, this is the ReactJS frontend running on localhost right now, served by Unit, and this is just a little example. We can type in a support case as the network. All good. Just thank you. Oops. Wrong keyboard layout. And email address, submit, successfully created, great. And then we have a little bit of a dashboard where you can see it's all good. Just want to say thank you. Small overview of our current tickets. All right, so let's dive into this a little bit. So this is our React app. Basically, we have our main entry point app.js. Then we have a dashboard component. We have our support request form component. One thing I want to point out is that we can use React Router, for example, to tell React, look, the dashboard is something in our React app, and / will be the support request. It was important for me to show you that React Router will work with NGINX Unit as well, because this is widely used to have routes like this in your frontend code. Okay, so support request component is nothing really special. It's a TypeScript created component. Basically, we have a service attached to it that's doing the fetch. And send a ticket to our, oops. Okay, now you should see my screen again. Okay. All right, so this is the service that will send the post request to our API. And one important thing that you can see here is we specify /ticket, then we send it via post to our API. This API is based on Python, and we do not have to do something like localhost port 8080 in this case, because it's all running on Unit, and I will show you how the routing works on Unit. One thing that is pretty handy when it comes to development, so that means here with localhost 3000, so let me open this. So this is the build version. So let's dig into 3000. So this is the current npm run version. And even here, I can say, all right, dashboard. And I can send a new support ticket. And the way how that works is this little setup proxy file here. And so this is very, very good because, it's useful because what we can say, look, everything that's like /ticket or any API context we have here with 3000 will target just localhost. And on localhost, we have NGINX Unit. So that means that even when I do live development and debugging, for example, I can work with my services as they should work in production, have this little setup proxy file in React to tell my React application, look, everything for /ticket can go directly to localhost port 80 or whatever you want to name it. Forget everything about port 3000 here. So that is this little helper script setup proxy, and it's nothing I built. It's a standard npm thing you can just download, HTTP proxy middleware. Pretty handy. All right. So the ticket API is, as we already told you, is running on Unit. So we have something like ticket here.
Timo?
And we have, yes.
I just wanted to, there's just a request from a couple of the attendees, if you could expand the size of the text of your screen. I don't know if you want to zoom out a little bit with your browser.
Okay. Is this better now?
I'm not sure, Timo. I would try to get it as a little bit as large as you can get it. I'm also going to say to all of the attendees, if you hover over the image, up in the upper right-hand corner, there's two opposing arrows. If you click on that, that will expand the image so that all you will see is just the computer image.
All right, so this should be. All right. Okay, so this is the proxy thing, and we'll go and see. And if this is not working, we can go into another version of, or I can edit it with the terminal. That will be fine. So, all right. So this is localhost port 8080 ticket, and this is the same API endpoint that just localhost ticket. Let me do this, because this will be much more bigger. So that should be big enough. So let's do this. Curl, and we have localhost /ticket. So this is the ticket endpoint running on localhost port 80, and we have the same endpoint just on port 8080. All right, so now let's see what we have on the unit side. So Liam showed you that Unit has a couple of configuration options, couple of objects like application, listener, route, and we're going look at those. So I have written a small unit CLI. It's hosted on GitHub. It's nothing officially from F5 or NGINX at this point. It's just something for me because it makes my life a little bit more easier. But I'm happy to share the URL with you so you can just go ahead and grab it. All right. So this is the unit configuration we have at the moment in place. It looks a little bit big right now, but I will break it down to its pieces. All right. So this is the listener part. This is like the layer 4. Means we have our listeners, port 8080, port 80, 9090. So this defines really the ports we want to open with unit. So then we have our application object, and this contains our applications. So we have the support API. We have our user service written in PHP, for example. This one is written in Python 3.9. Then we have a bit of a helper application as well. And let's have a look on our user service, for example, what we have here. So type is PHP. I think that's all clear. So then we can define an environment. So we can specify debug level, true and false. We can define our security solve, and we can send any environment variable we need or we want to our application. So the target part here is interesting when it comes to routing, and this is definitely something I want to point out today. We have two different targets, direct and index. So direct means anytime we send a request with, for example, PHP or for files on disk, we want to use this one, the direct endpoint. And for anything else, like a fallback, we want to send the request to the index PHP file of our application. So how that works will become very clear when we have a look on the routes. All right, so this was the application context. Now we have a look on the routes. So a route object in general has two main parts, a match and an action item. The match is optional, but I would not recommend to have a route without a match. And if you really want to have a route without a match with just an action item, keep that at the end of the list, because unit is like searching for matches, and if it can't find any match, it will respond within 404. And if you have, for example, a route that is just an action without a match, this will be like your default route, and this will then work around this 404. So that's why keep that at the end of the routes if you really need it. So we have a route named frontend. This name is really something you're totally free to choose, whatever you want. So then we have a match and the action. The match here says if the URI contains something like ticket, send this request to our support API. Or if the URI match something like /API, send it to our user service, to our PHP-based application. Or, this is the end of my front-end route, if it's not API, if it's not ticket, try to share the files stored on disk. So this is the like JavaScript files, images, CSS from our React app. If you cannot find a static file, send the request to our try files helper application. It's like to make the React router work. That's basically like the try files directive in NGINX. And no worry, we can host all this example code we have here on the GitHub repository later, so you can grab a copy of the code and can understand it and play a little bit around with it afterwards. So this is another route that's not used at the moment. So you can see you can have multiple routes with multiple actions in here. And yeah, so that's basically this concept of having a listener, a route, and an application. So, and now I want to show you something really new. And let me do this in here as well, just to make sure it is big enough for you guys. So we talked about having a JSON file or having this kind of configuration is very easy to automate. It's absolutely simple to describe what your application needs from the layer 4, from the very beginning, the network layer, till the middle of your application in the app stack, runtime, environment, files, all that things. And we were going to look at this abstract.json file, and so this is this combines so all you need in your application, everything that matters in your application is part of this application spec file. We have a listener that points to a route. We have a route information that says you have your user service, that's the name of the route. Everything that matches PHP goes to direct. So that means we want to get a PHP file executed directly. If it's not a PHP file, try to find this file on disk in the web root, like CSS, JavaScript files, fonts, whatever. It's static. And if you cannot find the file based on the request on disk, and if it's not ending with PHP, for example, send it to our application user service index endpoint. Oh, great. So let's have a look inside of the application. We have the target, direct, and index, and this is exactly what we reference in our route object. So this is the absolutely great thing here, that we can define from the early layer 4 listener settings till the very end in the application context environments, everything we need in a single file or in a single JSON configuration. So this is very easy. So I mean, you can automate it. You can ship it with your Git repository. Make sure your secrets are not part of it. Yeah, if you want, you can just push this to Git. And then to apply this to Unit or to create your application config with Unit, I can use my Unit CLI. I'll show you how it works. So there's a little helper to apply this app spec config to Unit. So this is something we can say use CLI -a, and then we have our abstract.json. Let's use the debug flag. See how that looks like. All right. So what we are doing is the ordering matters. First of all, we need our application, and if we want to proxy something, our upstream configuration. But for today, we have our application. So first of all, we have to create our application. All right, so this is PHP, our debug flags, everything. Great. After that, we can go into the network configuration and link the traffic to our application. So what we're doing here is we are applying the route configuration for our application user service. So we're creating the route. Looks familiar, I think. After that, we create the listener at the very, very end and say, look, pass everything, every traffic incoming on port 9090 to the routes object called user service. So that's the important thing, because the listener needs a configured route to work. The route needs the application, and that's why we have the application first. So even if you're not want to use the CLI for your configuration, make sure that you have the application first, then the routes, and at the very end the listener. Otherwise, you will not be able to configure. But as the as the CLI is just a wrapper around the curl commands for unit, you can at any time curl the unit's endpoint, the configuration endpoint by yourself without any problems. And as it is a JSON structure, you can simply add something like /config, /application, user serve, whatever, to get just parts of the configuration. So let's have a look how that works. So this is a Unix socket, and this sits here in user. Yes. There's a user local var run init. Yes, there's the control sock. So let's use this curl. And we have the Unix socket. So pipe that to JQ. So this is our overall configuration. And if we just want to have all our applications, for example, we can just say applications. And if we just want to see our user service, we specify the user service. And if we want to see our environment variables for this one, environment. Well, that's how it works. I mean, with a default JSON structure. So you can simply, so for example, if you want to automate the change of a password, of a secret with your CI/CD pipeline, the only thing you have to do is you have to reach the application server and send a post, or in this case, a put request to a specific endpoint. So for example, you want to change the debug flag to false, and then here, say this is environment debug. If we specify that with a put request to false, for example, we can change the values of our application during runtime without having a need of restarting, reloading, anything. Unit will take care of it. So we change an environment variable, for example, Unit will take care of a graceful reload of your application without having any downtime for your users. So this is how that works. All right. So as I said in this, that's too small probably. So this app-spec file, again, you have everything you need. The listeners, the routes, the applications, and yeah, environments. And another good thing I want to show you how that works is localhost ticket, and then we have localhost. This is the so this is localhost API. We remember everything that's API will be sent to our PHP service. So it's PHP 8 running on unit 122, and this is our API response for users index.json. Make it a little bit nicer here. This is coming from PHP, and as you see, it's all running on localhost without a single container, without any NGINX reverse proxy in front of it dealing with rewrites, with locations where I have to change the NGINX config file and then NGINX reload in the container, and all the things I did before is not needed anymore. Everything I have is inside of sits inside my app-spec file, and if I want to reconfigure my application, or if I want to reconfigure a specific listener, a specific route, all I have to do is to run my app-spec file, like we saw here, ucli-a appspec.json. It will reconfigure the listener, the environment, the application, all I have to do, and that's all I need to do. That's all. And I can, so what I love at this concept from an engineering or development perspective is that I have this app spec, this configuration in my project directory. It is at my inside of my project. It belongs to my code. It's not a reverse proxy configuration sitting somewhere else. It's really inside of my code. So that means if I want to see something, why are things like they are, I can just have a look in the app spec file, and it comes with my application code. All right, so this was for the PHP application, and it's the same fact for the Python application as well. So let's jump into this one real quick. Workspace. Oh. So this is Python application, and in my deploy config of directory, there is the appstack.json. So let's have a look at the appstack.json. Let's make that nice for us. And you see, it's the same style of configuration. The only difference here is it includes the overall listener on port 80 to serve our whole application with all the routes without having any ports. So that's the difference. But we have the listener's overall object, we have the routes object, we have the applications object, and as you see, we have Python 3.9, we have the working directory, the virtual environment, our environment. So that means if you want to change an environment variable for any kind of your APIs, it doesn't really matter if it's a Node.js, if it's PHP, Python, Perl, Ruby. If you have some sort of system changing secrets stored in your environment variables, it's a single implementation for all your APIs. It's regardless the language, how to configure the environment. And the good thing is that Unit will take care of gracefully reload the processes, the worker processes, hosting or shipping your application. So that means you're changing an environment variable secret, and Unit take care of restarting or reloading your application without having any downtime in front of your customers or users. That's what I love on this application. Server, reverse proxy, kind of web server. So it's very, very powerful. And with this app spec files, and it's absolutely simple to reconfigure. It's pretty simple to set up a new application for PHP, for example. Install Unit, install PHP, have an app spec template, push it initially to Unit, and you're all good. That's basically everything that matters. All right. Any questions? There's a question if use YAML for the app spec as well. Yeah, at the moment, the app spec JSON file, to be very honest, is something that is very, very new, and it's like my personal project. And I just pushed it to GitHub this morning. It was just on my machine, working for me personally. So at the moment, it's just JSON. Yeah, grab a copy and test it, enhance it, and let's see where it goes. So let's see if we can build a YAML formatter for the app spec file. Why not? We're not saying it's not possible. Would really love to see this one growing. All right. So a little bit of an advertisement. We decided to do some live coding and some live hacking event with NGINX Unit. And This will happen next Tuesday. And yeah, you can follow me on Twitter for more information about it. And what we are going to do is we will, in a very, very chilly and very, very calm format, we will hack a little bit around with Unit. We will maybe enhance this API demo. Maybe I will do some coding for my CLI. We will just hang around answering questions, do some checking, development, coding together, and have a great hour. That's basically what it is about. Again, it's March 16th, next Tuesday. It will be 6 p.m. Europe time. So follow me on Twitter to get more information about it. And yeah, would love to see a couple of you people joining and have a great hacking session. All right. So that's basically all from my demo. If there are any questions, something you want to see, let us know.
Terrific. Timo, Liam, thank you very much for the great presentation. I know that you have been answering the questions. Attendees, there's an offer just popping up, and check that out. There's a code there for the swag store. Make sure that you visit that for NGINX F5. And just as a couple of different things, there is a new question that just popped up. I'm not sure if Liam's going to answer that, but maybe Timo, if you wanted to hit that, it's under the Q&A. If you want to take a look at that.
Yeah, thanks.
Sure.
Reading that now. I don't know whether, Timo, we can race as to who's going to understand it quickly. So let me take a stab at it. Timo might improve my answer. So can we make services talk to each other? What we've seen with Timo's demo is multiple services built on different languages, providing a single application through through one front door, right, through one port. It is possible to have those applications talk to one another. Right now, you need to do that with NGINX Unit config by just having them talk again to that same localhost port, so they can communicate if you like. So that kind of east-west traffic is possible with Unit going through that localhost port. So it's not the most efficient way, and that's certainly an area that we want to improve and mature going forwards. But yeah, it's totally possible today, and I think we even have another kind of demo set up which might even show that working too. Did I get that right, Timo?
Sure. Yeah, we'll do some demo for this kind of stuff in one of our next live coding events. Why not?
And I'll take this next. There's a great question from Carlos about the security of maybe injecting code or against one application and injecting code into another application, if I understand the question correctly. So questions around best practices to avoid doing that. And for this, if you are running, and for simplification, we didn't show it in this demo, but if you got for each of the applications that's being handled by Unit, these can be run in their own C groups, isolated from the Linux kernel. They can be running under different user accounts, and they can also be running under different routed file systems. So, in fact, we've taken a lot of design has gone into avoiding one application taking down another, or being an attack vector to another application that Unit is running. It doesn't stop you from having vulnerabilities in the code, but it does stop one application from infecting or being a vector to an adjacent application that Unit's also hosting.
And Liam, it looks like there's one other question from Elaine.
Yeah, just reading that now. Okay, I'll take a stab at this, Timo, unless you've got a better answer. So this is not something that we can do today. So there's no the way you would, or that's to say, the way that you would be able to do this is you'd automate Unit's configuration with some intermediate shim that would be looking at Zookeeper and then applying the correct configuration to unit as things change in the Zookeeper registry or any other service registry. So for now, you need to do a little bit of manual work to have something monitor the registry and update unit, but it's been designed to be updated on the fly and as frequently as you like. So it's possible with a little bit of extra effort today until we're able to get that sort of integration built.
Great. So Timo and Liam, I'm going to just finish up with some housekeeping here. If we have another question pop up, of course, we can answer that. But I do want to thank you both, and I also want to thank F5 and the NGINX for their continued sponsorship of Dev Network's online learning sessions. And I'd also like to remind all of our attendees that there's handouts available. So make sure in your viewer, you go to the handouts section and download those handouts here in the next minute or so. And also, there is a recording of the session, which will be available in about 24 to 48 hours. That'll be emailed to you. You can email that out to your coworkers, or you can to anyone that you would prefer to take a look at it. It will also be available in our Dev Network content archive, and that can be found at devnetwork.com. Just a side point, Timo, the event that you were talking about on March 16th, where can our attendees get some more information about that event? Is there a spot on the website? Is there somebody they can contact to get some more information about participating in that hack?
Sure. So yeah, basically the best thing will be follow me on Twitter. Yeah, you can look at the GitHub repository as well. So we will announce it officially on Twitter with the @NGINX tag or hashtag. So follow the NGINX or me on Twitter, and then we will share links and times for next Tuesday for sure.
And actually, it just popped up thanks to our crack production crew. Those interested in that live coding session, you can register. It's pinned to the top of the live chat. So there is an Eventbrite link there. You can cut and paste that and go and register yourself for that live coding session. And that's, again, pinned at the top of the live chat. Additionally, in the chat, we just placed in the chat, if you have additional questions, you can email that to na_fm_NGINX@f5.com. So if you have additional questions, please do send that email or utilize the resources that Liam and Timo have up on the screen right now. So just to, it doesn't look like we have any other questions at this point. So I think we're going to close the event down. Again, Timo and Liam, thank you very much for the great presentation. A lot of great comments. A lot of people hung on and were checking out the demos, and was a terrific and a very informative session. And I want to thank all of our attendees for participating. Again, the recorded version of this session will be available at devnetwork.com in our content archive, and will also be emailed out to all participants, those who attended today, as well as who were registered and who didn't get a chance to come. So thank you very much, everyone. Thanks, guys, for your time today, and have a great day.
Thanks, everyone.
Thanks. Bye-bye.
Bye-bye.